Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Hello everyone, welcome back to Geeks for Geeks. This is another live session for Mock Live DSA. Myself, Abhinav Awasthi, I am a DSA mentor at Geeks for Geeks. I am an ICP seasonist, a 5-star at CodeChef, and an expert at Code Forces. Today we have Suryakant with us. Hi Suryakant, how are you?
Fine. How is it's my voice. Okay,
Yeah, I think you have some network issue. You can just take your time and correct it. No problem.
give me a sec.
Okay, guys, till then, just I hope you guys are also excited for this mock interview. Also, if you guys also want to be the part of these live mock interviews, you can just fill out the form which is given in the description box, and you can also get a chance to be a participant in this type of mock interview series at Geeks for Geeks. Sure. So we will start in some minute.
Yeah, I've connected back. Am I audible? Yeah.
Yeah, now you are audible. It's fine.
Okay.
So, okay, Surkant, are you excited for this?
Yeah. I'm really excited. Like on live stream, giving an interview. Yeah, quite fun.
Yeah. Okay. So, just Surkant, just tell me something about you.
Okay, so hello everyone. Myself Suryakant Pandey. Currently, I am at UIT Chandigarh, pursuing Bachelor of Engineering in Computer Science, and currently I'm in my fourth year. And I have done some web development, and I also done some competitive programming. So I'm 5-star rated on CodeChef and Night on Lead Code. Also in web development, one of my major project was an NFT based warranty system. Uh, so that's all.
Can you just please elaborate more about your projects?
Yeah,
Means
sure.
what you
So
have
NFT based
implemented.
warranty system was basically we developed the web application that was based on blockchain, which helps e-commerce sites to create an NFT of their products, and that could be then that could be then used by the seller to verify the product details and other stuff, and also that can be then used by the users to find the authenticity of the product, and also the then further it could be used for the ownership verification of the buyer. So that was the project.
Okay, great. It seems great, Surikant. So, let's start with the interview. So, I hope you
Yeah.
are ready. So, I have just shared a Google Doc link with you. Have you got
Yeah,
it?
I can see that.
Yeah, you can just open that document and screen the share the screen.
So, Is my screen visible? Is it visible? The screen share?
Yeah, now the screen is visible.
Okay,
Great.
okay.
Can you please just also zoom it out so that viewers can see it completely? Just zoom it out.
Oh, okay. Is it fine? Okay.
Yeah, now it's completely fine. Now it's completely fine. Yeah, it's great. So, okay, Suryakant. So the first problem is that I'm just writing the problem statement here only. Okay.
Okay, sure.
So this is the problem, Suryakant. The problem is that you are given with an array of n positive integers, and you have to reverse every sub-array whose size is k. So the
Okay.
thing is that let's take a sample case. Okay, so the sample example is something I am just writing here. This is the sample example. You can see that the value of n is 5 and the value of k is 3. That means you have to reverse every subarray group of size k. You can see in this array, which is of size 5, this
Hmm.
is a subarray of size 3. So we have
Hmm.
reversed it. And maybe at the last, you can get a subarray of size less than k. In that case, also you
Hmm.
have to just reverse it. Okay?
Okay. Hmm.
So this is the problem. So I just want from you that you can just give me the best approach for solving this particular problem and how we can implement this problem. Okay.
Okay.
So you can just write a
So,
pseudo code for it.
okay. So the idea that is coming into my mind is basically, okay. So we want to reverse every group, subarray group of size k. So what we can do is we can have a for loop which will jump at k steps. Okay. K, which will jump at a distance of k each time, and there would be a condition such that we could check if there is if I jump more k step one more time, if it is possible to be in the array only or it is going out of bound. If it is going out of bound, then we can just take the size of the array for that, and then reverse from this index to the end of the array.
Okay.
Mhm. Is
Okay.
my idea.
So
Okay.
yeah, it seems to be quite good. So you are basically saying that you will take a for loop and you will just iterate for the every kth subgroup. No? That is what.
Yeah, yes, yes.
Yeah. Okay, so just can you just tell me that how you will make the reverse operation? Let's say that you have a array, you have a subarray,
Hmm.
but how you are going to make the reverse operation? Can you just
Okay,
give me
so
some idea on that?
like for the implementation part, I could use the STL's reverse function, or I could implement a reverse function myself, which will basically what it will do is basically, let's say we have one, two, three, and four. So I will have two pointers, one at one and other at four, and then I will swap and move those pointer I and j one more time towards each other. So it will be like after first step it will be 4, 2, 3, 1, and my pointers will be at 2 and 3, and then also I will reverse it. So it will become 4, 3, 2, and 1. So the complexity of the reverse function is O of n, and space complexity of
Okay,
1.
okay. And what should be the I think that the complexity of this complete problem you just implemented? What will be its
Okay,
complexity?
so if I am implementing it, okay, uh, so I'm having a k jumps, and at each k jump I am reversing the array of size k. Huh. So I think the complexity would be O of n, big O of n, as we are having k jumps, and at each jump we are reversing the k subarray, the subarray of size k. So each element is each element is visited one time only, and
Okay.
that will cause to have a complexity of O n.
Fine. So just can you just please write a quick pseudocode for this problem? How you are just
Okay.
implementing it?
So let's say we have void.
So let me just give you a function. Just let me just give you a
Okay,
function
sure.
at that place only. So let's take that the function you are having is basically you are given a vector. Sorry. Let's say that you are given with a so you are given with a function. Let's say reverse groups, and inside this you are given with a vector v and the value of n, which is the size of the vector, and the value k, which is the k, means the subgroup size. And you have to basically, let's say, return this particular uh,
Reverse vector. Okay, sure.
reverse vector. Okay. So now how you will?
Hmm. Can I use the reverse function of the STL, or should I write the reverse function myself?
Okay. So can you just please tell me how the reverse function of that STL works?
Okay, so like the reverse function of the STL. Oh, like as much as I know, like it has uh, it has two pointers, and like the approach I already told you, I guess that was the implementation
Okay.
of reverse function. Uh,
Okay. Means
I
it is
don't
just
know,
a
but
two
like
pointers
there
approach.
could be multiple. Sorry.
That means you are saying that it works on the two pointers approach, no?
Yeah.
Okay. Fine. Let's implement that code.
So okay. So I will go with SQL reverse only.
Sure. Sure.
So okay. So we have equals to k. So we are having a k jump, and we could have n minus k, but we are not sure. Like, will it be? Okay. Let's go for this only for now. Okay. It would have n minus k jumps, but if there is, let's go for this only for now. Okay. So I will go from. Okay. I would reverse function v dot weekend plus I comma v dot weekend plus k. I would reverse this, or I would go with
Okay.
k minus 1, because if I can k, I think this would be fine. And okay, and not k, it's I plus k. Okay, so here I could have minimum of n comma I plus k, and oh, now I could close the loop. Can I just zoom out? It's a little bit bigger for me.
Sure.
Yeah, it's fine.
Sure.
Let me see. I can finally return the vector v. Just let me check. Let's say we have 1, 2, 3, 4. We would go for let's say k is equals to 2 for now. Uh, so we'll go from 1 to it would reverse this, and if I'm getting I plus k is more than okay, I plus k should be more than this, but there could be a condition if okay. So what I'm saying basically, uh, 2 will be a issue. I think 3 would be fine. So we would not 3. Let's increase the size of the array like this. Okay. So now what I will do is basically I will go to 0. I will reverse this array. It will
Okay.
become 3, 2, 1, and then I would have a pointer at 3. 3, yes, and I have size n equals to 3 and n equals to 5. So this is uh, it would go for there and it's fine. Okay. So I think it would work for now. Yes,
Yeah,
I think it
yeah,
would work.
yeah. I think that it's fine from my side. So just can you just please tell me about the time complexity and space complexity for this approach which you have written?
Mm, okay. So our space complexity is big of 1, like we are not uh, making any extra spaces. And let's go for time complexity. It would be okay. So we are having k steps. So the number of steps would be n by k, approximately, not exactly, but it could be. It would be n by k only. And for each step, we are going k times in the reverse function. So it would be n by k into k, which will like which will be n, like k will be cancelled and only n will be left. So the complexity would be O of n.
Okay, okay, great. Okay, Suryakant, fine. So that is what I was just searching for. It's fine. So that's fine from my side for this problem. So yeah, I think that now it's time for the next problem. Let's move towards the next problem. Okay. So the problem is something like you have to merge. I think that you have heard this one. You have to merge two sorted arrays.
Okay.
But there is also a twist. So I'm just writing here. So just move towards the. Let's move towards the next page. Okay, for this problem.
Okay.
Fine. Yeah. So the problem is that you have to merge two sorted arrays, but without using any extra space.
Okay.
Okay. So the thing is that let me just write the problem statement for you. So the problem statement here is this one, which is you are given with two sorted arrays, ARR1 and ARR2, and their sizes are given to you. They both arrays are independently sorted in a non-decreasing order. You have to basically merge these two sorted arrays. Means the final array should also be sorted. But the only thing is that you don't have to create another array of n plus m size. Let's say that
Okay.
let's say let me just give you example. Let's say that our array which is given to us is ARR of 1 is uh, okay. Let's say that ARR of 1 is something like 1, 4, 6, 8, 10. Okay. Similarly, ARR of 2 is something like 2, 3, and let's say 7. So the final array will be 1, 2, 3, 4, 6, 7, 8, 10. I hope this is right. If I will just merge these two arrays, this will be
Yes,
the
yes.
final array. So what I want that the final array should not be returned as a part of a new array. You have to just make changes in this array, and the first five elements will be in here because this size is 5, and the next element will be now in ARR2. So this will be the value of these two arrays after the operations are performed. So you have to do the in place merging without using any
Okay.
extra
Okay.
space.
Mhm.
The problem is clear now?
Yes, yes, yes.
Okay, so again, let me just give you a function for you to just write. So let's say that this is the function that which is merged. You don't have to return anything; just make the changes on that array only. And the first array is ARR1, ARR2, and the size is NMM of both the arrays.
Hmm.
Okay?
Understood. Understood.
Yeah.
Okay. No, okay. So let me just call this the original array. Yes. Okay. So what I want to do is basically okay. Hmm. I want this to be in this array since it is smaller than 4. Okay. Okay. So how would I do it? So if I'm finding an element smaller than this, I want this in this array. But okay, this is not. I'm not sure because like 4 could be in this array or could not be in this array. It could be shifted into second array also. Depends on the array, only. The elements of the array basically. Okay.
Okay.
Okay. So if I'm here and I have to,
You
uh,
can also just tell me
can I?
first the brute force approach, then we can move towards a more efficient one, if
Okay.
there's any.
So brute force approach, like with extra space or without extra space.
Yeah, brute force can be any
Okay,
approach.
anything.
Yeah,
Sure, sure, sure. Okay, so
exactly.
like one brute force could be we could like we could push back every element in a new vector and sort it, and then take the first n elements in the first array and second m elements in the second array. So that would be the first brute force. It would cause us O of n plus m complexity in terms of space, and
Okay.
n plus m log n plus m in terms of time complexity as we are sorting the merged array.
Okay. Fine.
Okay. So
Fine. So now how we can optimize it in a better way that the space complexes should be O of one only. And I think that for
mm,
this problem, as the arrays are already sorted, both the arrays, so the complex should be linear, the time complex should be linear in case.
okay. Okay. So I'm just okay. Yes, we can do that. What we can do is basically we have 2 and we have 4. Now, if we have 4 and we have a smaller element than this in the second array, we are sure that the last element of this array, because since it is a sorted array, so largest element would be in the end. So,
Okay.
okay, yes, I think I got the question. Just let me verify. Okay, yes. Okay, so since the arrays are sorted, if I'm finding the smaller element in the second array, which is smaller than any element, like let's say for 4 we are finding 2, we can
Okay.
just swap it with 10 since 10 is the largest element of the array, and if we have a smaller element which needs to be swapped or which needs to be placed in the first array, then there would be some element which needs to be get in the second array.
Okay.
uh,
Okay.
so I think I can swap these two, and okay, so and okay, if I find this I can swap these two also, because since we have two elements and we won't swap for this. So we would have something like error 1 is equals to 1, oh, no, not 2, 1, 4, 6, and 3 and 2. And we would have array 2 as what it will be 10 and 8 and 7. Uh, okay. And then we can sort both of this. Both. Okay, so I think this is the approach. Uh,
Okay.
okay. Yes, so the time complexity would be, but we are sorting it, it would be n log n. Hmm, n log n, like we are sorting it, yes, n log n. Yes, okay. Basically, n log n or m log m, whichever is the highest.
Okay.
And
Okay. So can you just please again repeat the approach what you were thinking of?
okay, yes, sure. So, like I would have two pointers, one in the array 1 and another in the array 2.
Okay.
Uh, so if I find a smaller element in this array 2, which is smaller than the current index, let's say we are at 1, we found it is larger than this, then we move the pointer to 4, and our this pointer is still at 2 because we didn't find any larger element, but at 4 we found it. So we would like for 4 we have 2 which should be in the array 1. So we can say that the largest element of this array would come in the array 2 only, because like if we are moving some element up, some element has to move down in the array 2 also.
Okay, yeah, fine, fine.
uh, yeah, that was the approach. So I would swap 10 and 2 like this. Then I will move the pointer to 3, and here also I'll move the point. I will keep the pointer here only to check if 4 is larger than 3. It is larger than 3. So again, I will
So
swap it with 8.
for that two, you have just continued. I mean, first you have compared between one and two, na? That is what you are saying.
Yes, yes,
First
yes.
you will compare with, so after comparing one and two, what you will do?
If 1 is smaller than 2, then I will move the first pointer.
Okay, fine. So now the pointers
And
are at four
if
and
not,
two.
then I will, sorry.
Now the pointers are at 4 and 2.
Yeah, 4 and 2. Now I find that 4 is larger than 2. So 4, so the basically the idea is basically 2 is smaller than 4, and if we are having a merge sorted array, then 2 has to come in the array 1 only. It can't be in the array
Yeah.
2 now.
Okay. Yeah. Fine. Got it.
Yeah, so to swap this, is it clear, sir?
Fine. Fine. It's
Yes,
fine.
sir. So
Okay.
after doing this,
Just
we are sorting both the arrays, and the time complexity is O of n log n, and space complexity of is also big O of 1 because we are not using any extra space. So this is the approach. Should I code now, or is it
yeah, sure, sure.
okay?
You can continue with the approach.
Okay. So okay, let's see. Let's go with pointers only. Uh, I could have the pointers around. So I is representing array 1, J is representing array 2. Okay, so let's say we have a while loop while I is less than n, or should it be what? Let's see. I'm not sure. Should be or, I guess, because okay, because if we are at the end of this, still we will do like if I have a pointer at 10 and a pointer at 3, still I would compare the elements like 10 and 7. So it there should be or. Okay, okay, sure.
Fine.
Hmm. So what we can do is basically, okay. So if ARR 1 of I is less than ARR 1 of J, hmm, what do we have equal duplicates elements?
No, let's assume that we don't have duplicates.
Okay, we don't have duplicates. Okay, so there would be a lesser than, like the element would be smaller or larger. There couldn't be any element that would be equal in the both the
Yeah.
arrays.
Yeah.
Okay, sure. So let's not. I think we could do this and else. So we have else part. Uh, Let me just zoom out a bit. Not okay. Okay, fine. Hmm. There should be array 2, not array 1. So let's say we have a greater element. So what we wanted to do is basically, where is it? Yeah, yeah. What we wanted to do is we would swap it with, okay, we need another pointer for that. K is equals to n minus 1, as we are dealing with n, my first array first, okay. So K would be n minus 1. So I would swap ARR 2 of J and ARR 1 of K. Is it okay? Yeah, it's fine. And what I will do, I will do basically J plus plus and
Okay.
K minus minus also.
So
Okay,
that
case versus it should.
okay, got it.
Oh, sorry, k minus one. Let's say this. It's the line is colliding with each other. I am not able to see correctly k minus one,
No,
but it
it's
is k
fine.
minus
It's
one.
fine. It's fine. I've got it.
So okay, I'm doing I plus plus. So this is more than j. Hmm. Okay, so in last, what we have to do is basically sort ARR, ARR one comma ARR one plus n, and sort ARR two comma ARR two plus m. And before we just do that, let me just check for the while loop. I'm not sure about the while loop, about this or condition, because like there could be some overflow. There could be some overflow. Let me just check. Mm, they're also doing k minus
There is
one.
a time when maybe I can become n. So in that case, this will go out of bound. Index out of bound
Yes,
exception
yes,
will be
yes,
there.
that's what I was thinking.
So
Uh, okay. If I go, okay, I think I could do this. I could go with and if I am at the end of an array, I could just do nothing, because like okay, hmm, if I'm at here,
uh,
let's say take this example. After which,
I think that after every swap in the second array, you have to also sort the second array so that the elements of at least one array are still be sorted. Because when you are just making the swap operation, so that is completely fine. That for the first array, you are sending it the smaller element. But for the second one, let's say that
hmm,
when you will swap, when your first pointer will be at the fourth of the array one, and let me just explain you that there.
hmm,
Let's say that your first pointer is at here, okay, at this particular element. I hope that it is
okay,
visible. And the second is at 2. So when you will make the swap operation, here you will have 2,
okay.
and here you will have 4. Getting? But in this case, now
Oh,
your array is not sorted. So in that case, you have to in each swapping you have to also sort the second, which is the m array. So that will just take off m log m, okay, and that will be completely fine. And this is all you can do. I think that the other integration part which you have done is quite good. Means you have just used the 2 pointers, but there are some test cases, there are some corner cases where it may fail, and because of just one of the corner case which I have told you, that here I think that it should fail. What do you say?
mm, let me just rethink about it. I'm not sure, because like what you said basically was this, but okay, so what like okay, so like my
Just
approach was like this.
yeah, you can give me a
I'm
counter
just saying that if I
condition.
have a smaller element than this and I'm doing it here, so my k pointer would play a role here, because like if like there is a smaller element here and we are swapping it with this, and we are having a k pointer also, which is pointing at this now after the swap
Okay,
here. So if I could use k pointer to know, like k pointer could tell me na, ki where the last swap was where and till when the array is sorted. Like in this case, till here the array is sorted,
okay, okay,
and
fine.
then I could know which part of the array is not sorted, because this array will be sorted everywhere every time. Like I'm at 1, I'm at 2, I'm swapping it, I'm moving at 3, so I'm not doing anything after this, after 3 7, uh,
Okay.
and so this array is not the problem, I think. Is it okay? Because Like don't
Fine,
think
fine,
like
fine.
this is not the problem
Can
because
you
we are
just
putting.
can you just again explain the code, the pseudo code?
Sure, I will dry run it for you.
Yeah, sure. Thanks.
Let me just, I was thinking something here. If I would, okay, let me just make the approach clear for once again. I think
You can
this
use the
should be the.
comments to write on the code, the comment to write on the code, or you can just take a dry run for me to explain, so that it's
Yeah,
a
sure.
bit more
I'm taking
clear.
a dry copy on this one. So let's say where
Fine.
I 0 and j is 0 and k is n minus 1 for now.
Okay.
So the first iteration will occur. I will just check for 1 and 2. So since 1 is smaller than 2, we have no issues because in the merged array also they will be small. Like it would come after that only, after 1 only. So we
Okay.
will do just I plus plus. So I will become 1 and j will still be 0, k will still be n minus 1. And what we can do now is basically we have 4 and 2. Now 4 is larger than 2 and in the merged array 4 should come after 2. So what we
Okay.
will do, we will swap this with this. So what the array will become is basically like this. We will swap this and this, and we will move the pointers. Let me just for you. The pointers would be I will be there only. J will become 1 and K will become n minus 2.
Okay.
Will be here. J will be here only, and our sorry, I will be here only, and J will be here. Now what will happen will we will compare these two, and still 4 is larger than 2, 3. So we will again swap it. So the arrays will become like I think like this. Uh, it would be 3 here and 8 here, and our pointers would be like uh, our pointers would be like our pointer will move to 2. This would move to 3 and minus 3. This will move to 6 only, and our
Okay.
I is 1. Now I will compare 4 and 7. So I can say that 4 is smaller than 7, then it is okay. And now if I move to 6, I can still compare 6 because like the value of k would be 0, 1, 2, and I would also be 2. So I can compare this index for now, but I cannot move move my k pointer from this point. So what I can say is basically this will be the final array. Once my I become more than
Okay.
k, I will just uh, I
Okay.
think I
Okay.
will
I've
try.
got it. I've completely got it. I've completely got it. So just go again to the code part, the pseudo code part.
Okay, so my I, j, and k were this. This was the array. I have j pointer and I pointer. If array 2 of j is larger than array of I could just do I plus plus because like 1 and 2 case. If I have 1 and 2, like in this part, where it was, like here, I
Got
and
it.
j. So I
Got
could
it.
just
Got
I plus plus. Then I could swap the last elements and increment the j pointer and decrement the k pointer. And lastly, I could just sort those two arrays.
fine. 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 It's completely fine. I've got it. So just can you just please tell me about the time complexity and space complexity for this problem?
Okay, so we are
To for that.
sorting both the arrays. So whichever is higher, I would say big time would be big of maximum of n comma m. Should I write like this, or I could convert it into n log n something like that?
It's fine. Yeah.
Because
It's fine.
it
It's
depends
okay.
on the size. Like okay, okay, sure. And since it is a two pointer, so it yeah, it would be time n log n also only because we are sorting the array. And the complexity of while loop would be uh, I plus sorry n plus m, and the sorting complexity will be n log n. So the maximum one is n log n. So time complexity will be n log n, and space complexity would be
Okay.
big of 1 because we are not using anything. We are just swapping in the array and sorting it after the loop. So this would be the thing, I guess.
I think it will be better if you write your time complexity as n log n plus m log n.
Yeah, sure. M log M. Yeah, sure. Plus. There should be a plus.
Yeah,
Oh, is it okay?
yeah, it's fine. It's fine. No, it's great. So fine, fine, Surkan. That is what I was just asking from you. So it's fine. Means you have optimized it in a good way, and the Dryden was also working fine. So overall, the approach which you have used is also completely fine. So we have some time. We have some 10-15 minutes. So let's go with the another problem and a really exciting one. So I just don't want you to just code that problem completely because maybe that will take more time. We don't have much time. I just want from you a good approach for that problem. And till now, because of both the problems, you have given a great approach. So I hope that you will just go right. Yeah, Tuhin, the given arrays are all are sorted only. Okay, they are sorted. Fine. So
Okay. So we have
so
multiple arrays or single array?
no. No, I'm just writing the
Okay,
problem.
okay,
Just a
okay.
minute.
Sure, sure.
This is the problem.
To convert into a palindrome. Okay.
So you are given with a number of characters, or basically you are given with a string, and you have to find the minimum number of characters to be added in a particular string to make it a palindrome. Okay. So for
Yeah.
example, if the string is ABCD, so it will become
Hmm.
like this, which is
Okay.
BCDA, and you can say now this is a palindrome string. So this is what you have.
Can we? Yeah, just a doubt. Can we insert at any position?
Yeah, sure. At any position,
Okay. Okay. Sure. 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 Great.
you have to just count a minimum number of insertions required.
Okay.
You can just come up with the approach
Okay.
what you're thinking for. If you are able to find out the approach for the approach, then also it's fine. If any other approach, then it will be fine. So
Okay. Hmm. So we have to. Okay. We could insert at any position. Hmm. Convert it into a palindrome. Okay. So palindrome. Hmm.
I hope that you know whether what is a palindrome string.
Yeah, yeah, sure, I know. Palindrome is basically if you reverse the string, both strings should be, same.
Yeah,
The first half, reading it from starting and reading from end, both should have same,
yeah,
strings. Okay,
exactly,
understood.
exactly.
Hmm. So, okay, so I think let me just, uh, so what I was saying is, hmm. So we could, okay. Hmm. In order to find minimum number of strings to get it, characters to get it, okay, inserted. Okay. So let's say we have something like A, B, C, D, A. So we could just insert C at the end. We could find it. Okay. Hmm.
Just giving you a hint. Just giving you a hint.
Oh,
Okay.
okay.
Can I? If you need, otherwise it's
I
okay.
have an idea for now. Like I'm
Okay,
not
sure.
sure, but I'm thinking something like this. So if we have A, B, C, D, I would just have two pointers at A and D. Mm, hmm. Okay, so I'm thinking something like if I would iterate through A, B, C, and D. Okay, and I would try to find it at the end of the string if I am able to. So, like in this, let's say we have a better example. Let me write one more example: A, B, C. So let's say like this. Okay, so we could just insert it here. We could insert here only. No, not here. Like this. Okay. Hmm. At each position, I have an option to insert at the back. Hmm. So if this is the string, what I would try to do is basically I would try to find this character at the end of this. If I'm
Okay.
unable to find it, I will just insert it here like this, and
Okay.
I will move the pointer here. And again, I
Fine.
will try to find this in this, but I'm not able to find it. So I would insert B here one time. Now I will go to C. Then I'm able to find C. Then I will move both the pointers. Like this pointer will go to A, this pointer will go to B, and these are not equal. So I could insert B here. One time.
Great.
So this becomes a palindrome, but there is an issue because a better approach is like we could only insert this. Uh, uh, what was it? Uh, C, C, yes. So this was the original string. So we could insert C here only, and this would become a palindrome. Okay.
So
So the
if you
approach
can
that is
just
coming
figure
from
the things.
currently, yes.
Hmm.
So the approach is like the first approach I only told you. Like I would try to find this at this position. If I am unable to find, I will insert an element, and then again I will move pointer J here. I means I will move the pointer here, and I will try to find if this is possible. So I could do it two times. One with this like the string only, and other with this reverse string,
Okay. Okay.
and I
But Suryakant, there is a corner case. The corner case is something like, let's just give you a example. Okay, so let's take that, just like here what you are having was, it was like, where is it, like it was
it was like
BACA, then CA. So you can see that in this string, if there you will just add a B here, it will be a palindrome. Okay.
yes,
So for that you are
yes, yes.
saying that yeah, we can just make it like that. But you can observe one more thing. Let's say I have just removed this A from here and B from here.
Hmm.
So it will be that in the first case you have to insert a B in the right side and a in the left side.
Hmm.
Getting, but if you will
Yes.
reverse, so if I will just follow your approach, you can see here that if I will just follow your approach, you will first check from here that B is not present, add a B. Then C is not present, add a C. Then A is not present, add a, so A is present. This will be your string. Okay.
Yes, yes,
But
I'm able to get it because there could be an insertion at any position. So I was thinking of
basically,
inserting at the end
your
only.
logic was absolutely clear that you have to check for the first element also that whether it is present at the last or not. Similarly, you have to check for last element whether it is present at the first or not. Fine.
Hmm.
But
Yes.
this can face in every position, in every
Yes,
comparison this
yes,
can
I'm
happen.
able to understand it. Like, which the examples I took, it has like it would work only for the elements. For if the question was like we are able to insert and delete insert elements at the end of the endpoints of the string, then it would work. It won't work if we are allowed to insert at any position. Hmm.
Yeah, it can work, but basically it works when you are just taking from a single side. That you are basically what you are
That's
doing. You are
all
just
right.
inserting element at a single time, at a single side, either on the right or in when you reverse it, then on the left, basically. So just your approach is very clear. Just think a little more, and you will get the solution. Can we do a recursive approach here?
Yeah, I'm thinking about that only. Just give me a second. Hmm. Okay, so I think I have an idea. So, what recursive approach would be like? What I'm able to think about it is basically, what? Okay, yes, I think I got it. So our we would have two pointers int I and int j in the recursive state. Okay, so if these two are equal, let's say for what? Let's say for this only. If these two are equal, then we could decrement both of these, Okay.
Okay.
So what is the idea? If both are equal, if s of I, let's say s of I equals to s of j, then we could decrement every like I would do I plus plus, increment the left pointer and decrement the right pointer. And if they are not equal, then we have two options else. Then we have two
Okay.
options. What are these? Either I could insert it here, or I could insert an element here which is equal to
Yeah.
this.
Exactly.
So we could have a recursive answer of int answer is equals to minimum of answer comma. We could have a recursive, let's say a function. Should I write the function?
Yeah. Sure. Sure. Sure.
Sure. Okay. So I would just do it in that only. So let's say not would, it should be int min insert ins min ins. Let's say like this. And we have a string s and int I and int j. And okay, so if I is equal to j, then we would return 0 because we don't need any we don't need any more insertions. And if s of I is equals to s of j, then what we could do is we could basically do I plus plus, or we could have uh, return okay, it would be min ins of s comma I plus 1 and j minus 1. Should I add something? No, there shouldn't be anything. Else what we could do is basically we could either end answer is equals to minimum of answer comma. Let's say for now, we are doing it for I could say we could do it for I plus one. Okay, so we could do it for I plus one. It means let me just think about it. No, we could do I plus one, and we are saying that. Let me write just like this, and not j minus one. It should be j. So
I think
let's
that you have got the problem.
yes, yes, I
I'm just
think
getting
I'm
that.
able to. I would write the recursion, and I think I could write the DP also. DP would be of two state and cross n, and we could use this in that. If I have I plus one, I could, if I have a and b at I and j pointer, I could say that I have inserted a here, and I could move the pointer from a to I plus one, and j pointer would be there only, like this,
Yeah.
and not semicolon. And similarly, there would be j plus one, j minus one. Answer equals to minimum of answer comma um, min insertion j comma sorry I comma j minus one, and I think I could return answer here.
Exactly.
Uh,
Exactly.
and I could
And
just
I
memorize it.
Yeah, and then that will be DP. I got it. I got it completely, Surkan. So fine, Surkan. So as we are also done with the time, so it's time for the feedback session. So first of all, let's first talk about all the three problems. Sorry.
Should I close the doc?
No, no, no. Don't just unshare it. You can open that screen. You can open that screen yard. I have just removed your screen from there. No problem.
Okay. Okay, okay. Got it. I got it.
Yeah. So, okay. So, Surikant, so for the three problems, means for the first problem, it was a quite easy one because just wanted to start from easy problem, just to know that how you are just performing. And for the first problem, you have just done a well thing, and you have used the reverse function, how you are reversing, and that is what I was figuring out, just thinking of. And the most challenging thing in that problem was how we can find a time complexity, because maybe someone will just confuse that it is n to k or something like that, but that is also what we have just got in a
Yes,
good
yes.
way.
I was a bit, confused at first, but
Yeah. So basically,
it was
you
okay.
are
It was great.
you, yeah, you have told us the exact thing that we are just iterating for each element just once. when we are reversing it or anything other thing. We're just iterating once, so it's just O of n. And if you talk about the next problem, which was again a hard problem, and which is merged to sorter using the same, which it means merging two arrays is a quite of similar, easy problem of 2 pointers, but without using an extra space. That was something hard to
Yes,
implement.
that was a
That's
big
also,
problem. Like,
yeah, exactly. But yeah, you have just done it wonderfully. And I was just not expecting that much of, but yeah, you have done it wonderfully. And the thing you were just approach about the 3 pointers, I, J, and K. So that was really nice how you were just swapping, how you were just comparing with the first element of the first array and swapping with the last element of the first array. That was a very amazing logic which you
yes,
just thought.
that was very tricky. Like I was not sure like it is correct or not, but I did some
Yeah,
dry runs and I was thinking like it was correct.
yeah, maybe it means I have some doubt with the corner cases. Maybe it can, but I think that it will run for the most of them, and it should be right. It should be right. And I was just thinking of another approach, but the approach you just came with up is also quite good. Now for the third problem, it was a really difficult problem of DP. It was a dynamic programming. I was not expecting from you that you will just solve it in the last 10 minutes, but yeah, you have got it, and you have solved the complete problem in the last 10 minutes.
Right.
So that was really impressive.
The
So now
recursion
let's
was a great help, I would say.
yeah, that is a great
It was
problem. I was just thinking to take that problem before that merge two sorted arrays, but then I think that as I see your profile, your resume, that you are good at DP. Just play something with arrays and then move to the DP part. So that's really amazing. Now the time for the feedback session. So you can just scroll down to the feedback part.
yes, sure.
Yeah. So here I've given you in the coding skills 4.5 out of 5 because the way you have just thought of the thing and that was completely fine. The way you implemented the first problem, just use the reverse function, the last problem using the recursion and that DP thing you have told me two states. And for that 3 pointers approach for the second problem, the implementation was really great. For the communication, I just give you feedback from my side that like when you were just thinking in your mind or when you're just trying to get on the problem, just make it loud. Means when you're just debugging your code, in that case you were just talking by your own or just thinking on your own. Just make it interactive with the interviewer also, that yes sir, I'm just I was thinking this, but that may fail at that per case, so I'm just changing this thing. Or like in the second problem, you were just thinking it by your own that yeah, I've taken 3 pointers. Means I even thought not getting was, then that was the case. That just be interactive with the interviewer. So it is just otherwise it was also good. And for the speed, I have not expected for the last problem. So the speed is for the last problem basically. Means like you have just done it in the last 10 minutes, and also the first problem was also done in the last first 10 minutes. So it was also amazing. Great. For the second problem, you have taken some time to understand it, but overall it was a good one. So overall, it's just 4.5 out of 5, and that's from my side. You can now unshare your screen. It's fine. And also, any feedback from for me, Suryakant?
Sir, like I have nothing to say. Like you were great, sir. Like you were quite supportive, and like you were able to clear the. Basically, when I was lagging, like you helped me, so it was great.
Yeah. Okay, thanks. Okay, guys, so this is all for today. I hope that you have loved this particular session. If you also want to be a part of this type of live mock DSAs, you can just check out the link which is given in the description box, and you can fill it out. You can also get a chance to be a participant in these type of mock live DSAs. Okay, guys, then thank you for joining the stream. Thank you. Have a good day.